Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Rizkia Zahra. I'm from group 5 and I'm here. I want to explain about the vocabs, more problem from the video and more examples. Okay, let's get started. In the first vocab, we have algebra, or in bahasa we say it aljabar. Algebra is a branch of mathematics that use mathematical symbols and operations such as addition, subtraction, multiplication, and division to solve problems. Example, x squared plus 2x plus 5 equals 0. Next is coefficient, or in bahasa we say coefficient 2. The coefficient is a number that contains or shows the number of variables in algebraic form. Examples, 9x, the number 9 is the coefficient. Okay, next we have function, or in bahasa we say fungsi. The definition of a function in mathematics is a mapping of each member of a mapping set if and only if each member of set A, or called the domain, pairs with exactly one member of set B, or called the codomain. Okay, this is the example of function. Okay, next we have greater than, or in bahasa we say lebih dari. Greater than is a mathematical term used to compare two quantities and helps establish a relationship between two quantities where one term is greater than the other. Okay, example, 5 is greater than 3. Next, we have greater than or equal to, or in bahasa we said lebih dari sama dengan. The greater than or equal to symbol is used in math to express the relationship between two math experience and used to compare two quantities where one term is greater than the other term or can be equal to the other term. Okay, this is the example. This we will read. 5 is greater than or equal to 2x. Okay, next we have less than, or in bahasa we said kurang dari. A less than sign is defined as the math symbol used to compare numbers where one value is less than the other. It is an inequality symbol used to show the comparison between two or more quantities. Example, 6 is less than, I mean 2 is less than 6. Okay, next we have term, or in bahasa we say suku. Terms are variables and their coefficients, including constants, in algebraic form separated by addition or difference operation. Okay, this is example of term. Next is factorization, or in bahasa we say faktorisasi. Factorization in mathematics is the decomposition of an object, for example, a number, polynomial, or matrix, into a product of other object or vector which when multiplied together produce the original number. Example, 3 times 2 is a factorization of the integer 6. Next, we have digit, or in bahasa we said angka. A digit is a symbol for a number or several numbers that is used to express the value of a number. Digits in English are called numerals. Okay, example, 15 is a number written with 2 digits, namely 1 and 5. Next, we have number, or in bahasa we say bilangan. A number is an arithmetic value used to represent quantity. A number is an amount of something. It can be written with one or more or many digits. Hence, a number is a mathematical concept used to count, measure, and label. Okay, number have many types. Okay, the type is prime and composite numbers, even and odd numbers, fractions and decimals, rational and irrational numbers, natural numbers, integers, real numbers, whole numbers, and rational numbers. Okay, this is the examples of number is 2 and 5.5. Okay, next we move to the video. Okay, from the video we have two problems. The first problem is 3x plus 5 is 17. First, we add minus 5 from both sides, and we have 3x is 12, and we divided by 3 from both sides, and we have x is 4. Okay, this is the illustration. 3x from here, 5 circles from here, and 17 circles from here. Okay, and next, this is the second problem from the video. Is 7x minus 2 is minus 10. First, we add 2 from both sides, and we have 7x is minus 8, and we divide it by 7 from both sides, and we have x is minus 1 and 1/7. Okay, this is the illustration. Okay, next is example 7. This is the question. Allison and Rachel were competing in a race. Allison had a 10 minutes head start and was running at 3 km per hour. Rachel ran at 5 km per hour. In how many minutes did Rachel catch up with Allison? Okay, this is the solution. In this problem, the key factor is that at the moment that Rachel catch up to Allison, they will have traveled the same distance. Okay, distance traveled by Allison is distance traveled by Rachel. Allison ran 10 minutes more, which will be represented by t plus 1/6 since 10 minutes. So, let t is Rachel's time, and t plus 1/6 is Allison's time. The units of t must be hours since the rates are given in hours. Okay, this is the formula of distance is rate times time. Okay, next we substitution the numbers, the value, and is 3t plus a half is 5t, and we subtract 3t from both sides, and we have a half is 2t, and we divided both sides by 2, and we have t is a quarter hours, and it's same with t is 15 minutes. Okay, next to check, we compute the distance traveled by each girl using is t is 1/4 for Rachel, and t is 1/4 plus 1/6 is 5/12 for Allison. Next is Rachel's distance was 5 times 1/4 is 1.25 km, and Allison traveled was 3 times 5/12 is 1.25 kilometers. So Rachel need 15 minutes to catch up with Allison. Next, we have example 8. Okay, this is the question. If Joe can paint 5 rooms in 8 hours, and Samantha can paint 3 rooms in 6 hours, how long will it take them to paint 7 rooms working together? Okay, this is the solution. Using the rate formula, we see that Joe's rate of work is 5/8 room per hours, and Samantha's rate of work is 3/6 or a half room per hour. Okay, let's see is the time to complete the job together. Okay, total number of rooms painted is painted by Joe plus painted by Samantha. is 7 is 5/8 t plus a half t, and 7 is 9/8 t, and we multiply by 8 from both sides, so we have t is 6 and 2/9 hours, so they will take 6 and 2/9 hours to paint 7 rooms if they working together. Okay, next is example 9. Okay, this is the question. It takes Susan 10 hours longer than Laurie to take their store's inventory. If it takes 3 and 3/4 hours for them to do the job together, how long would it take Susan to do it alone? Okay, this is the solution. Since Laurie takes less time to complete the job, we will let her time by percentage by t. So Laurie's time is t and Susan's time is t plus 10. The number of jobs considered in this problem is 1. Okay, so Laurie's rate is 1/t and Susan's rate is 1/t plus Susan's rate is 1/t plus 10. Okay, one job is amount done by Susan plus amount done by Laurie. Okay, next using 3 and 3/4 is 15/4. So the amount done by Susan is 1/t plus 10 times 15/4, and the amount done by Laurie is 1/t times 15/4. Next, we substitution into the preceding model. One job is amount done by Susan plus amount done by Laurie, and this is the model. Okay, we have 1 times 1/t plus 10 times 15/4 plus 1/t times 15/4, and we have 1 and 15/4 times 1/t plus 10 plus 1/t, and it's 4/15 is 1/t plus 10 plus 1/t, and we have 4/15 is t plus t plus 10 over t times t plus 10. Multiplying both sides of the equation b, the last common denominator, is 4 times t plus 10 is 15 times t plus 10. Okay, this is the 4t square plus 4t is 15t plus 15 times t plus 10. Next, simplifying, we got a quadratic equation, and this is 4t square plus 4t is 30t plus 150, and we subtracting 30t and 150 from both sides, and we have 4t square plus 10t minus 150, and we dividing all terms by 2, and we have 2t square plus 5t minus 75, and we can now factor it and solve, and we have t is minus 7.5 or t is 5. Note that the combined rate is equal to the sum of the individual rates. Since the problem requires physical time, we reject the negative answer, and we see that t is 5 is Laurie's time. Thereof, Susan can complete the job in 5 plus 10 equals 15 hours walking alone. Okay, the last we have example 10. This is the question. At the chocolate factory, John's job is to experiment with mixing different amounts of milk and chocolate to find different flavors. If he mixed 2 quarts of type A, which contains 15% no chocolate, with 1 quart of type B, which contains 10% chocolate, he creates type C. What percent of type C is chocolate? Okay, this is the solution. In this situation, the rate is the percentage of chocolate. For each type, we have the relationship is amount of chocolate in the type is percent of chocolate times amount of type. Okay, in type A, we have 0.15 times 2 is 0.3 quarts of chocolate. In type B, we have 0.10 times 1 is 0.1 quart of chocolate. Next, for mixture type C, we have 0.3 chocolate type A plus 0.1 chocolate type B is 0.4 quart of chocolate. Next amount type is 2 quart of type A plus 1 quart of type B is 3 quart of liquid. Next, we calculate the percentage that is chocolate is amount of chocolate over amount of type, and we have 0.4 over 3, and it's 0.13333 and more, or in percent we have 13.3%. So the percentage of type C chocolate is 13.3%. Okay, this is my explanation about vocab, problem from the video, and more examples. Thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.